all the best. And I trust that you will be successful in tomorrow's assessments because we have revised a lot for this assessment. Okay, let's see what we have today. Today we are doing Ohm's law, resistors and circuits, resistor codes, calculations of resistance, voltage, and current. Okay, so we'll be doing a lot of those calculations, right? And we're looking at the relationship between voltage, current, and resistance. Okay, I hope you can all hear me. If you can't hear me, please, if you can't understand, please talk to me in the chat box. If there's something that maybe I'm passing too quickly, just talk to me in the chat box so that you understand the lesson, okay? Because some of these things can be tricky in this lesson, all right? Now, just to recap, we talked about tools that we use in electrical systems and control. Now there you have your ammeter. An ammeter is always connected in series with the part of the circuit for which you measure the current, so that it measures the full current through that part of the circuit. It has a very small resistance so that it does not change the current in the circuit, okay? So that is your ammeter. Ammeter is used to measure what? What do you use the ammeter for? We are measuring what? Grade 9. What are you measuring using an ammeter? We are measuring current. We use an ammeter to measure current. We use an ammeter to measure current. Okay. A voltmeter. A voltmeter is always connected in parallel with the part of the circuit for which it measures the potential difference between 2 points. Very little current flows through a voltmeter since it has a very high resistance. That is why we have to connect it parallel with the part of the circuit we want to measure voltage. So a voltmeter is used to measure voltage. An ammeter is used to measure current. Okay. Then we also have a multimeter. Okay. What is the multimeter? Okay. I lost my connection for a while there. I'm sorry about that. How to use a multimeter? Okay. I asked a question, what the multimeter is measuring here? What is the multimeter measuring here? Is it voltage or current or resistance? Which is the correct answer? It's measuring, very, very good, Cleo. It's measuring resistance because it has a resistor, okay? So the resistance is being measured here. So this is one of the ways you measure resistance. Good, Tando, good. So now, this is how you connect. I showed you in the other lesson, the connections. When you are measuring resistance, you have to look for the ohm sign and you put the red lead there, and then you put the black one on the common. And then you adjust this selector to the resistance. And then that's where you will get the reading on the screen of the multimeter. So I have a question. What two tools can you use to measure current? There are two tools you can use to measure current. Can you name those tools? What are the two tools you can use to measure current? An ammeter, and what else? What else? And a multimeter. You can use an ammeter to measure current. You can also use the multimeter to measure current. What two tools can you use to measure voltage? Two tools you can use to measure voltage. A voltmeter and a multimeter. Good, Cleo. A voltmeter and a multimeter. Give me the two ways of measuring resistance. Two ways you can use to measure resistance. The multimeter, you can use the multimeter and the color codes. Okay? Tando, to measure resistance, you can use the color codes and the multimeter. So the multimeter is one tool that can measure voltage, current, and resistance. Okay. These are the color codes for resistance that we were using yesterday. Okay. What is being displayed by this band, which is separate from the other three bands? What do we call this band? It is the band. The what band? Tolerance. It measures tolerance, okay? What are these three bands measuring? Or these four bands measuring? What are they measuring? They are measuring resistance. Yeah, right, clear. They are measuring resistance. So these three bands or these four bands, depending what type of a resistor it is, they measure resistance. And this one band that is separate from the others is measuring what? Tolerance. Now, let us look at Ohm's law. Can you state Ohm's law? Please state Ohm's law for me. How can you state Ohm's law? Or for the separate band, can you say it measures the accuracy of the coded resistance? The accuracy of the coded resistance, or it measures tolerance. We say it measures tolerance, okay? So there, Amra, you say law stating that electric current is proportional to voltage and inversely proportional to resistance, okay? Or put in plain English, is that current will increase with voltage, provided that resistance is constant. This is correct, and it shows that you understand it. You know, the way that you must state Ohm's law must just show that you understand the relationship between these three variables, okay? Right, now let us look at the formula that we use to calculate voltage, current, and resistance, because these are related, because in a circuit, you find voltage in the power source, current, and resistance in the output components, okay? Now, V here is the potential or voltage difference measured in volts. V stands for voltage. I is current measured in amps. I. So I here stands for current. Okay? And R is resistance measured in ohms. So here you get the symbol for the formula. You know that I in the formula in the calculation will be representing current, and the units for current are amps or amperes. R represents resistance. The units for resistance are ohms. Okay? Let's see. R. Where is R? There is R. R is equal to voltage divided by current. This triangle will help you remember. R equals voltage divided by current. Current equals voltage divided by resistance. Voltage equals current multiplied by resistance. So this becomes very important when you are doing your calculations. Okay? Do you understand this? You won't forget this, will you? Okay. Understanding Ohm's law. What does Ohm's law say will change in a circuit when the resistance is kept constant, but the number of cells in series is increased? What will change? What does Ohm's law say will change in a current when the resistance is kept constant, but the number of cells in series is increased? What will change? Tando? remove voltage, it is current. Because when we are adding the number of cells, we are increasing voltage. So Ohm's law is saying current will change if we increase the number of cells. If we increase voltage, current will increase too. Yeah, Tando. Yeah, current will increase with voltage, provided that resistance is kept constant. You see? So that is what Ohm's law is saying. Okay? So when you add the number of cells, you are increasing voltage. So you will also be increasing current, provided that resistance is kept constant. Right? How will the current change if the voltage supplied by the battery of cells is kept constant, but the resistor is replaced by another resistor of a lower resistance? How will the current change if the voltage supplied by the battery of cells is kept constant, but the resistor is replaced by another resistor with a lower resistance? If in a circuit there is a resistor, there's an ammeter, this is the power source, the current will increase. Okay? The current will increase. Listen, remember, the resistor restricts the flow of current. That is the function of the resistor. So, in this circuit, you have 4.5 volts of power source, but you have a resistor there. So it is resisting the flow of this 4.5. When you can measure with the ammeter here after the resistor, you will find that this 4.5 volts of current, it's not coming here to the ammeter. So the ammeter will not reach 4.5. Okay? So this question is saying, how will the current change if the voltage supplied by the battery of cells is kept constant? This has not changed, ne? But the resistor is replaced by another resistor with a lower resistance. If you lower the resistance, then more current will flow, and what will happen? Then the current will increase. So you are understanding Ohm's law like that. How would you describe the relationship between current and voltage in a circuit? How would you describe the relationship? They are in direct proportion to another. Normally, without resistors, without us connecting resistors, if we connect voltage and we add the voltage, so the current will be increasing too. The only thing that is disturbing this relationship is resistance. If you understand that, then you'll understand Ohm's law. Okay? Current and voltage are in direct proportion to each other. That means they are working hand in hand. Okay? If you increase the voltage, you increase the current. You decrease the voltage, you decrease the current. The only thing that will disturb the relationship between voltage and current is resistance. Because remember, we said in a circuit, current will flow freely until there is something that is going to restrict it. And now that is a resistor. Right? When one changes by a factor, the other one changes by the same factor. For example, if one is increased to 5.5 times its value, the other will also increase 5.5 times, okay? If one is made a third of its value, the other one will decrease to a third of its previous value, only if resistance is constant, okay? I hope you understand that. Right. There are questions. Which of these changes will cause the current through an electrical circuit to decrease? Right? Write down all the letters of the statements that are correct. Okay? What is it that will decrease the current? A decrease in the voltage, a decrease in the resistance, an increase in the voltage, an increase in the resistance. What is it that will affect, that will decrease current? I want your answers. Yeah. Tando said it's B, C. Who is this one now? Let me see. Law stating that electric current is proportional to voltage and inversely proportional to resistance. I want you to choose from this, okay? Which one will affect current? Okay? It's A and D. A decrease in voltage, that will decrease current because they are married, eh? And also an increase in resistance. Remember, resistance restricts the flow of current. So this is what will decrease current, these two things, a decrease in the voltage and increase in the resistance. That will decrease current. Next question, an electrical circuit has 1.5 volt cells in series, has 3 1.5 volt cells in series that is connected to a lamp and a resistor in series. Which of the following things would cause the lamp to shine less brightly? Write down all the letters of the statements that are correct. An increase in the voltage of the battery. Add another cell. A decrease in the voltage of the battery, remove a cell. A decrease in the resistance of the resistor. An increase in the resistance of the resistor. Which ones would cause the light to shine less brightly? Good. B and D. B and D. You're right. Bucks. You're right. It's B and D. A decrease in the voltage of the battery and an increase in the resistance of the resistor. That is what will cause the light to shine less brightly. Now, let us look at the calculations. Calculations using Ohm's law. Now, this is just an example. Example 1. Calculate the value of the resistance in the diagram below if the voltage across the resistor is 12 volts and the current through the resistor is 2 amps. Now, there's your battery. It's 12 volts. How many cells do you have there? 1, 2, 3, 4, 5, 6, 7, 8. Okay. Now you are calculating resistance. There's your resistor 1. There's a question mark there. So this is what we must determine in the calculation. So we have a voltage of 12V. There, it's 12V. So there's our voltmeter. It's 12V. Now, we want to find resistance. What is the formula for resistance? The formula is voltage divided by current. So voltage is 12V divided by 2 amps. And we want the resistance. So the answer will be 6. It should be 6 ohms, not 6 amps. The answer should be in ohms. So the answer is 6 ohms. Okay? That is the calculation for resistance. You used this formula. And resistance is measured in ohms. Okay. There's another calculation, an example. We are using the formula now. Example 2, calculate the value of voltage supply in the circuit below if the resistor has a value of 4 ohms. There's the resistor, 4 ohms. And the current through the resistor is 2.5 amps. There's our ammeter. So we want to find what is the voltage here. Let's see. So the formula for voltage is current multiplied by resistance. What is our current? 2.5 amps multiplied by 4 ohms. So our answer is 10 volts because voltage is measured in volts. So our answer is 10 volts. Okay? You understand these calculations? Grade 9. Remember, we are using this. We're getting our formula from this one. Okay, this triangle. Okay. Are you with me? Example 3. Calculate the value of the current in the circuit below. Calculate the value of the current in the circuit below if the resistor has a value of 3 ohms and the voltage across the resistor is 12 volts. Okay, let us look at the formula for current. I think my calculation is wrong here. Current is voltage divided by resistance. Okay, let's do the calculation. Voltage divided by resistance. So it's 12V divided by 3. This formula is wrong. It should be I divided by is equal to voltage divided by resistance. This formula is wrong, but the calculation is correct. So we divide 12 by 3. The answer is 4 amps. Okay, 4 amps. So the formula is the one wrong thing here. Okay, right. Right, now let us look at the calculations that you have to do using the examples that are done for you. What will the potential difference be if the current in a circuit is 10 amps and the total resistance is 1000 ohms? So what are we looking for here? We are looking for voltage. We have to calculate voltage. Please do this calculation and quickly give me the answer. Voltage. How do you calculate voltage? Let me bring you here. This is how you calculate voltage. Voltage equals to current multiplied by resistance. You are going to multiply current by resistance. What is the answer? Woza, grade 9? Grade 9, are you still there? Yeah. 10,000. Okay, let's see. Tando Ngubane said 10,000. 10,000 volts. You're correct. Voltage equals to current multiplied by resistance. So that's the calculation. Voltage is 10 amps multiplied by 1000 ohms, and the units for the answer will be voltage because we are looking for voltage. So when the question said what will the potential difference be, we know that because we are doing an Ohm's law calculation, so the potential difference will be that of voltage. Right, given voltage is equal to 10 V and resistance to 1 kilo ohm, what will the value of the current be in a circuit? Current. Current. How do you calculate current? Let me take you back to the triangle. Current is equal to voltage divided by resistance. So calculate. Calculate quickly. What's your answer? Ten. Tando said 10. Let's see. It's 0.010 amps. Why? Because the 1 kilo ohm is actually 1000 ohms. Remember when we did the kilos and the megas? We said a kilo means times 1000 and mega means times 1 million. Okay? So this is the answer. Your current is what is the formula for your current? Voltage divided by resistance. So you're going to divide voltage by resistance to get this answer. Quickly calculate. What is your answer? Let's see. What is your answer? Yes. 0.02. Okay, Tando. Let's see. 5,000. The 5 kilo ohm is 5,000. Okay, so your answer is 0.004 amps. Okay, a tumble dryer in a laundry service uses 220 volts power source. The coils of a heater provide an average resistance of 12 ohms. What is the current flowing through the heating coils? Again, you will use the formula because you are looking for current. You'll be using this formula for current. Your answer should be in amps. You will divide voltage by resistance to get your answer. $18.33 or 18.34. Yes. Yes, Tando. 18.3 amps. 18.3 amps. You're correct, Tando. Okay. A 9-volt battery maintains a current of 3 amps through a radio. What is the resistance in a circuit? So to calculate your resistance, what is the formula for your resistance? It's voltage divided by what? By current. Okay. There is your formula. When you are looking for resistance, voltage divided by current. Do your sum quickly. Do your calculation quickly. Tando, have you finished? What's the answer, Tando? 3 ohms. Tando said it's 3 ohms. Let's see. Very good, Tando. 3 ohms. If the voltage across a circuit is increased 4 times, what would you expect to happen to the current through the circuit? When you increase the voltage, We must all chorus now. We must just all chorus because we all know the answer for this one. It is the basic answer of Ohm's law. The current will increase by 4 times. Very good, clear. Clear. The current will also increase because we say current, voltage and current are directly proportional depending on resistance. Right. In the circuit below, calculate the value of the resistor. What is the resistor? What is the value of the resistor here? And your answer should be in ohms. Okay, how do you calculate resistance? Resistance is voltage divided by current. Do your calculation. What is your answer? Tando. Tando said 3. Okay, let's see. It's 3 ohms. Correct, Tando. Right. I hope you understand these calculations, ne? Okay. If 2 more cells are added to the circuit, will the current increase or decrease? Check your prediction using the formula. There, I have a quick answer there. Bright Tando. Okay, let's see. This is a 9V battery, and we are checking the current. Okay. The question is, if 2 more cells are added to the circuit, will the current increase or decrease? We know that the current will decrease, will increase. But let's check the answer here. It will increase by 2 cells. Means 2 times 1.5 V. That is 3 volts extra. Okay? So this will be 12 volts. Okay? So the current will increase also. Right? So this is the calculation. Voltage equals to current multiplied by resistance. So current equals voltage divided by resistance. That is 9V divided by 3 ohms. Okay? And then, which is equal to 3 amps, which is bigger than 2. Okay? So the voltage will increase by 3 amps. Okay. I'm happy that you understand. You understand we can do more and more calculations of Ohm's law. Calculate resistance, calculate current, calculate voltage, as long as you know the formula. Then you look at the circuit, you look at the values, then you can predict the answer. Calculate the battery voltage for the circuit below. Okay, that's the calculation. Voltage is equal to current multiplied by resistance. So voltage, which is 0.5, current, which is 0.5 amps, multiplied by 12 ohms, which is the resistance, because for voltage, you must multiply. There's an equal sign that is missing here. You must multiply current by voltage. Then the value of this battery will be 6 volts. The answer is 6. Calculating current, look at this circuit. You have 12 volts battery there. And then we don't know the resistance. Here, resistor 1, but resistor 2 is 12 ohms. Okay, and on these 12 ohms here, we have 6 volts. Okay, calculate the current through resistor 2. So when you're calculating the current equals volts divided by resistance, that is 6 volts, right? And then you divide that by 12 ohms, then you get 5 amps, okay? 5 amps is the answer. What will the current be through resistor 1? There, we have a question mark. Let's calculate that. 0.5 amps. The resistors are in series, so the same current flows through each resistor because they are in series. If it's 5 amps on resistor 1, it will be 5 amps on resistor 2. What will the voltage drop across resistor 1 be? Voltage, it will be 6 volts. Okay? It's 12 volts minus 6 volts. So remember, a resistor will be resisting the flow. Okay? What will the resistance value of resistor 2 be? It will be 12 ohms. It has the same voltage drop across as it has a resistor 2. Okay, so those are the calculations. Our time is up now. Let me love you and leave you. I hope that you did understand the calculations of Ohm's law. Okay, have a lovely afternoon. Have a lovely evening, in fact. The sun is going down now. Thank you. Bye.